Good morning. My name is Paul Bergquist with Skyfoundry. Thank you, John, for having us here today. Skyfoundry is the maker of SkySpark, data analytics software. Everybody hear me okay? Should I use that?
You can either use that or you can use this.
All right. So Skyfoundry is the maker of SkySpark, data analytics software that automatically analyzes the data coming out of your building automation systems, utility systems, smart metering devices, asset management systems. So what we're going to talk about today is data analytics and improving the facility of operations with that data. And the story really starts with data. There's a tremendous amount of data coming out of today's building automation systems. But how do we turn that data into actionable information? How do we turn that into real dollars of savings? And you might notice this slide today looks a little blurry. I like to think that's intentional. Those are the bits and bytes, millions and billions literally of data points coming out, or sensor data points coming out of your systems. And how do we bring that data into focus, right? The question is, if you could see that data more clearly, are there dollar signs hidden within that system? And so what we're going to talk, we call that information alchemy, turn those bits and bytes of data into real dollars. Do we know how our systems are really operating today? How was it designed to operate? Was it programmed correctly? Was it commissioned? Was it commissioned completely when it was? Was it commissioned through all seasons and all modes? And a lot of times when buildings are commissioned, they're commissioned in a manual way. They're not really commissioned in auto mode. So how do you know that your system's actually going to work in auto over the life of the system? The other question I would ask is, did the balancers do their job? And is that data persistent? Is the data and the way the system is balanced today consistent with the way it was designed to operate? Are things overridden? Are schedules and set points changed? And none of this information, these questions I'm asking, these aren't answered with a traditional building automation system. We have alarms and we have trends, but there's nothing today, in most cases, looking at that data to determine if these things are persistent over time. So why do we care? Why do we care how our buildings are really operating? Well, if we knew and had a better understanding of how our systems were operating, we would begin to reduce operational costs and meet the ongoing and increasing regulatory requirements. And in turn, we'd have an increase on our asset value, an increased cash flow, and we'd have ability to meet increasing societal and social demands placed on us by our tenants. Right? Here's a data point for you. Studies continue to show that real estate owners see higher financial returns when they excel in energy efficiency and sustainability. The Carbon War Room found that a 1% increase in REIT's global real estate asset sustainability benchmark score corresponded to a 1.3% increase in its return on assets and almost a 3.5% increase on its return on equity. We have lots of technology. Some of you indicated you are on your third and fourth generation of building automation. We have dashboards. Many of you probably have dashboards. You probably use energy analysis tools, and I'll make a distinction between analysis tools and analytics tools. But it's still a big challenge. I'll give you an example. One of our early customers was Duke Realty, 700 Class A office buildings. They took our technology, I have a case study up here, and deployed it on 122 sites. And the first thing they did was they brought in exactly 2 points of data. They brought in their interval kW meter data, and they brought in expected occupancy. And within a very short period, they had huge financial returns just by looking at that energy curve and identifying equipment running too early, too late, off schedule. One specific example with Duke, they were looking at these energy curves, saw that something was running outside of schedule, called down to the building operator. We see the building's running unoccupied. What's going on? Oh yeah, I overrode that schedule. We had a special event, so I forgot to put it back into auto. Well, when was that? That was last September, right? And those are real problems. Those things happen today. So what happens at the next event? What happens if that schedule's, overridden again next week, next month, next year? And there's got to be something that tells us what's happening. So who's watching to make sure? Who verifies that what the operators are doing is correct, that the control strategies were doing what they were designed to do, and were the assumptions when it was designed, are they correct? Are they still correct based on our current space usage or occupancy? Are they running, is the systems running as expected, or are they overridden? One of the things we see quite often is sensors and other devices have ultimately failed. We have a rule in our built-in analytics function that look for failed sensors. And all the time we hear from our building owners, all our sensors work. All our sensors have been tested, they all work. And our partners drop the sensor failure rule in there and automatically scans. Every day it looks for sensors that failed in every single job site that this has been deployed on. It's found broken sensors. Take those results back to the owner, and always the response is, oh yeah, that's a VAV box that we have overridden. And no one knew why. They knew it was a problem. It was overridden, and it's hard to see at any one instant in time that the sensor isn't currently reading, because it might be reading 73 degrees. Buildings are just simply too complex, and there's just too much data coming out of these systems to be analyzed by a human. I'll give you a small example. 1,000 data points. A lot of you have big systems. 1,000 data points, control points, 10 years worth of data, 15-minute intervals, is 3.5 billion samples of data. And how can any human begin to understand that data? Just too complex, too much data. So how do we know where to focus? I don't know if anybody in the room ever feels like that person up there. Vast quantities of data. We have some analysis tools, and we have dashboards to help bring that into focus. But how do we know where to look? How do we know, even if we had a dashboard on all our different screens or on our different pieces of equipment, how do we know where to focus? And I think a customer summed it up best. They said, dashboards are great and analysis tools are very helpful, but I need someone to tell me when I should look at the dashboard, to tell me there's something there that's important that deserves my attention. As if I had an experienced mechanical engineer constantly reviewing the system operation 24/7. And obviously that's simply not sustainable or scalable. So what is the solution? Analytics is the solution. Analytics, when I talk about data analytics, is software that automatically looks for issues, things that matter to you in our data. We have a fully programmable auto analytics platform, but it ships with over 500 analytics rules. So you could we call them functions. You could drop those functions in as a complete rule, but they might not be exactly what you want. Some of our competitors out there are offering analytics products that are pre-programmed rules. They think they know how your equipment and your buildings are supposed to run. We take a different approach. We believe that's up to you. We believe that you know best, and your consultants working with you on how your equipment systems are supposed to run. And we give you the foundation, and we let you customize that based on your needs. Analytics software looks for equipment faults, deviations from expected performance. It can automatically calculate your energy intensity metric. For example, kW per square foot per degree day might be the metric. And if you're on a campus, college campus, or might be the number of students occupied. In other words, or another number of classroom hours. In other words, you can customize your energy intensity metric based on your production metrics. If you're a hospital, how many beds are occupied? If you're again a classroom environment, how many students, how many classroom hours, how many widgets in a factory, so on and so forth. And unlike other energy efficiency measures that involves installation of major capital equipment costs, analytics works with the data that you have already that you're probably just archiving and not doing a lot with. So it's relatively easy to add to what you have and to start getting immediate value from it. So here's the bigger picture. You can hardly open up a paper, look on Twitter. You can't look at the news today without seeing something about data analytics. Analytics is changing our world, no question about it. From building deeper customer relationships to fighting crime to increasing your sales. Analytics is changing our world, and it can change the way your buildings operate too. Your CFO or CEO want to run your business without building or business intelligence software. Why would they expect that you run your buildings without building intelligence software? So this is how we would apply analytics to your particular facilities. We would take data in, data that you already have. That slide's a little bit skewed, but I'll try to read it through it for you. If you have BAS data, most of you probably do, that's great, but it's certainly not required to do analytics. A lot of very valuable analytics projects have been done without live building automation data. If you have it, that's great. We take BAS data in through a variety of sources: BACnet IP, Modbus TCP, Sedona, the new Haystack protocol, just about any modern IP protocol we can bring directly into the analytics platform. We also bring in facility data. Why might we want facility data? Well, if we bring in the geo address, for example, we can automatically correlate the weather for your particular facility, so we can normalize your energy use and compare between facilities. We can also bring in square footage, again, for energy normalization. We bring in utility data that can come from your BAS, come from smart devices, can even come over the internet through web services. For example, if anybody's heard of the new green button protocol, utilities are making energy data available in a standard electronic format on the internet. You can bring that directly into SkySpark, even if you don't have comprehensive meters on your facility. We can bring in weather, as I mentioned, calculate degree days and energy intensity. We can also bring in, I mentioned, production data. Number of widgets factory produces, occupied square feet office buildings, number of beds occupied in the hospital, classroom hours, big box retail might be the revenue per month, so on and so forth. We bring that data into an optimized database for doing analytics, a database that's highly efficient at dealing with the vast quantities of time series building automation data, and we run your fully programmable rules against that data. Those rules look at the data constantly, and one of the neat features of SkySpark is if you think of a new rule, a new theory you want to test on the way into work tomorrow morning, program that rule in, and it'll look back in the data as far as you have data to see if those situations ever happen. That distinguishes it from a lot of other tools out there that really only look at the current situation or maybe going forwards. We have the ability to look backwards through the historical data as far back as you have it. So what's the result? These are just some screenshots. Obviously, in a limited time we have here today, we're just going to give you a snapshot. We do an hour-and-a-half online demonstration just about every week. If somebody, if people are interested, I'd be glad to hand out the information for that, kind of get a soup to nuts overview of the software. But in this case, here's the result. Across the top, you can see a site level portfolio view of when deviations happened. It shows you a timeline here. It shows you the relative duration, relative placement of these issues detected by the rules that you have programmed into the system. Continuously and automatically scans your data. When you drill down a little further in the lower screenshot there, you'll see it automatically brings in the weather that's correlated with that piece of equipment with that site. Again, shows you your what we call the spark line, which is the timeline of the details for when the event occurred. And below that, we also bring in all the I/O points associated with that piece of equipment so that you can see what was happening when the issue was detected with all the I/O points on your air handler or with your piece of equipment. This is unique in that when you go here to look at the Spark detail page, a lot of times you gain insight into what the equipment is doing that without this visualization you never would have seen, right? You have all the sensor data out there. These screens are automatically generated. There's no programming involved based on your tagging of the data, bringing the data into the system, and the rules you write, it automatically creates all the visualization. No HTML programming, no dashboards, no programming on your part. And that's a huge benefit because these automatically generated screens gives you deeper understanding, deeper insight into what your equipment is ultimately doing. So that's a result of analytics. Every screen, every report cannot be auto-generated, auto-emailed to your cells or to your employees based on their role in the system. So what data? You can get started with the data you have today. You don't need live data, real-time access to every sensor, every point in the system to gain real benefit from your analytics. We can take in live data and we can take in historical data. There's great value in just dealing with small snapshots of might be CSV interval meter data that you already have without additional capital expense. And it's really not a competition. There's really no benefit one way or the other to static data versus live data. There's great value you can get from either one. Using existing data greatly reduces your cost of getting started with analytics. So what can you achieve with limited data? Again, we see many projects start with just limited amounts of CSV data. You can see buildings that are starting too early, buildings running too late, buildings that operate continuously. Look at your demand peaks, your peak load, and deviation of your energy intensity metric, whatever it is, and correlate that and track that against your benchmarks and your baselines and your goals. So with more data, BAS data, we can look further down and drill down deeper. We can look for simultaneous heating and cooling, for example, something we commonly see. We can see this in single units or in group units, so it's more applicable to big box retail. We can look for short cycling, long cycling, and lack of diversity control. We can detect degradation of heating and cooling performance, for example. You might only be getting 4 degrees delta T across a coil when you would expect 8 or 10, but we're in the swing season, so it might not be an issue, but it's an indication of a problem you might have later on when the season gets more extreme, and that's something you can detect before it's a problem for your people. We can detect economizers open while we're heating and cooling or non-functioning sensors. I'll give you the example of a failed sensor, something we see quite often. Lights overridden, and one of the biggest ones is set points not changing with expected schedule. And this is just a brief list. It's really, these are some simple examples, but can get much more detailed based on your equipment and building types. So what are the results? Here's an example of a real business case. Exceptions happen, schedules get overridden, we know that. But the question is, how long do they stay overridden, and what is the cost? And so in this example, there was a simple rule that was applied to look for things that were in the overridden mode or override mode and auto-generate reports and send to the managers based on those findings. And the result in this case was $1.8 million annually across 925 retail sites with one simple finding, and that rule was applied to building automation systems of many different types. Because our software runs, the analytical rules run in the data layer, we don't have to get into the individual control systems to program. We can run at a higher level with that normalized data and effectively run one rule against all your different systems regardless of who programmed them. Here's another example of some findings that we've achieved. Simultaneous heating and cooling. So obviously the goal is to achieve desired comfort with the least amount of energy. So the solution was to apply analytics to automatically detect improper operation. And in this finding, control sequences were changed to achieve $325,000 annually across 67 sites. And the analytics function looked for simultaneous heating and cooling for packaged rooftop units. Here's some other examples. I've mentioned a couple of them already. Anybody in the room know what a pitot tube costs by chance? Rough estimate. Anybody have any idea? $15? Wrong. It costs $1,300 when it's clogged. Just an example. It can cost an enormous amount of money when the sensor isn't reading properly, but very difficult to detect. With analytics, you can detect a sensor that's stuck or not reading properly over time, and obviously take a huge load off your fan system. Example in the upper right corner of a hospital in the Pacific Northwest that was detected night setback control wasn't active. So the 100% outside air makeup units for the operating rooms were essentially not setting back their temperatures, and you can look at the savings there. Avoided energy costs and then the resulting energy units. The lower left example of VAV boxes that were just commissioned. Brand new VAV boxes just commissioned. Must be working perfectly, right? Well, in this case, they weren't. And we see that quite often. A lot of times when new systems are tested, they only sample 15–20% of the boxes, or they just don't have time to test them in every single mode. So how do you know whether or not that's what the box is going to do long term? Mentioned the simultaneous heating and cooling in the lower right, detecting demand peaks, and we're able to avoid 11 months of demand penalty charges based on knowing when you're approaching the peak and notifying somebody and being able to do something about it. So here's a summary for the value propositions of analytics. You can't control what you don't measure, and driving energy efficiency and cost reduction through data is proven. SkySpark Analytics alone, much less our competitors, are in 8,500 sites worldwide, over 475 million square feet under SkySpark Analytics. Analytics enables you to know how your buildings are actually running, not how you hope they're running. And we're able to validate against industry benchmarks and internal goals. Supports measurement and verification, portfolio assessment, and we can do automated reporting to regulatory bodies, such as we can report directly to the Energy Star portfolio manager. We like to say it's easy to get started, and what data do you have? Often the savings are in the range of 5 to 30%. The thing about analytics that's difficult to predict is, we get the question all the time, what is the return on investment? Well, we often ask the question back, are you going to fix everything we find? And the response usually is, we don't know what you're going to find. Therefore, it's pretty hard to calculate. But in other words, the analytics, in most cases, find things that require action, right? So they find things that require action. The actions you take are what result in actual savings. So we like to say it's time to stop archiving your data and to start generating value from it. I'll be glad to take some questions. Before I do, I'm just going to leave you with this kind of lighthearted cartoon. So I would ask you, technology is changing our world and it's changing the way that buildings operate. So are you the kind of person, are you kind of the company, you the kind of business that is looking at technology for what it was, what it used to be able to do for you, or are you looking at it through a new lens, what it can do for you going forward with modern technology, with modern things like data analytics? That's all I had. I'll glad to take some questions, and I would encourage anybody to come to our deep dive presentation, hour and a half, soup to nuts overview of our software. Give me your card. I'll make sure you get an invite to that. Any questions?